Hello, everyone. Welcome to a new episode of our Lunch and Learn series, where we bring interesting topics from the world of tech and web development right to you. Remember that if you're watching us live, you can ask your questions using the YouTube chat, and we will answer them at the end of the stream. Today, we have Gabriel Bandeira with us, software engineer who works with our client FreshBooks as a tech lead. He will tell us all about hexagonal architecture with Python. Hey, Gabriel, how are you doing?
Hey, yeah. Welcome everybody. My name is Gabriel. Software engineer. I work in IT industry as almost 6 years. I would like to talk a little bit about hexagonal architecture today. And yeah, let's go deep and take a look about hexagonal architecture. So here's some context that we're gonna follow up. First of all, we're going to talk about a little bit of history of hexagonal architecture. Then we're going to talk about the introduction about hexagonal architecture, and then we can explain what are the main ports and adapters, and also get a little bit of specific stuff around what are primary adapters and secondary adapters. At the end, I'm going to show you a little bit of project structure example using Python. So let's go. So basically, the history of hexagonal architecture starts with Alistair Coxburn in 2005. He basically evolved from a work that's called ports and adapters. The main idea of the hexagonal architectures, it's around inside, surrounded by outside. The inside represents our business logic, and outside represents things like external systems, UI, and other interfaces. So Alistair Coxburn, he basically had an issue in his in the company that he was working on, and the problem was basically because he was developing a service with a whole database structure that was necessarily something that was necessarily that he needs to build in a tiny space of time. So Alistair made like, hey, how can I do this in a tiny space of time and have a really good work with a really good code that is testable, maintainable. So basically, Alistair proposed the idea of ports and adapter that we're gonna talk a little bit about that, and then he actually created the idea of the hexagonal architecture. So in the end, he was able to actually spin up the net new service with everything around the database side, and his work was done in time space of time, helping the company with their time box. So yeah, obviously the first start of the hexagonal architecture. Then we can talk a little bit of what is this hexagonal architecture is. So it's really modular, testable, illusionally coupled system. The heart of the hexagonal architecture, it's domain that represents basically the business logic with well-defined boundaries that we're gonna take a look in the next slide a little bit about that. So yeah, it's pretty much about this. And the hexagonal architectures, one thing that is important, it's the segregates the infrastructure, the components from external dependence from the domain. So as mentioned, the domain is the center, like the center is the heart of the hexagonal. That is the self-contained environment. This is really important to have in our minds, because having this concept, we can basically understand why this is like a really maintainable code, because your business logic, it's really self-contained in a specific environment. So yeah, in going a little bit of talking about a way that we can explain the hexagonal architecture in an image, I tried to create this image to give a little bit of the idea around. So at the center, we have the heart of the hexagonal architecture, that is the domain, which is represented by an hexagon. Around the domain, we have the ports that we're going to take a look a little bit of in the next slides, and the adapters. So the hexagonal architecture, it's basically surrounded by those things that we're going to take a look in the next slide. So first of all, what is the domain? So as mentioned, the domain is the heart of the hexagonal architecture. Is the place that you have your business logic. So you have your entities, your values objects, and your use case. So it's totally independent of external concerns. Is also focused on solving business problems. Here at the bottom, I have example how we can basically show how the domain parts and adapters look together. And yeah, let's take a look a little bit of right now about the parts. So the parts are basically a way to abstract the interface between the adapters and the domain. And with the part, you can basically create an abstraction of something that you want to adapt. So imagine that you are trying to adapt on clients, and this client is going to talk with external service, or this client is going to talk with database. So for that, you can abstract one class, giving this whole idea. So having this abstract class represents your part. And as I mentioned, the part, it's one way to actually talk with the external world by connecting those things with the adapter. Yeah, let's see a little bit of talk about the adapters. So the adapters, it's basically the implementation of the parts. So as we talked, the parts, it's basically an abstraction layer. That this layer is saying like all methods, all things that we can abstract in aspects are something that we want to adapt. And the adapter is the really the place that you gonna write the code and say for the parts that those methods do something. So basically, we can define those adapters in two different ones. The first is the primary adapters. The primary adapters, they basically are called as adapters. People usually call as only adapters. And the most important thing that they are entry point into the service or the application, such as APIs, CLI, or another ones. And the secondary adapters, also called as host adapters, are really specific to a particular external database, like Flask, Django, that we're gonna take a look further. So let's talk a little bit about the primary adapters. So the primary adapters, as I mentioned it before, it's basically the place that you can implement something that you abstract in the part layer. So imagine that you need to talk with your database and say, hey, database, get me something, or create something, or delete something. So using the primary adapters, you can create, for example, database repositories that gonna implement the logic around that. Also, talking about the adapters, we can say that you can, for example, also create adapters for a client that's going to connect with the external service. Imagine that you have a payment service or something like that. You can define this logic inside the adapters, giving the abstraction layer that you created, giving the abstraction layer that you created using the ports. So here are just a few examples of primary adapters. We can basically, a primary adapter could like implement the data transfer objects, DDOs, and domain entities. You can have as well the package, libers, clients. Here are just adapter examples. As I mentioned, we can have different adapters So you can have as well the Mongo database repository adapters or MySQL adapters or RabbitMQ adapters. So you can have a lot of different adapters in this layer. Um, and going further, we can take a look about the secondary adapters. So the secondary adapters are also really important because they are called as host adapters. And inside these host adapters is the place that we're gonna basically implement again the parts, but with the idea right now to implement this layer of your host. So imagine that you need to define your API requests, or you need to wire your application using dependency injection, for example, or you need to have a few settings, or you're gonna need to create your host. You're gonna need to have like a framework for that. So all those things gets inside the host adapters. Here are just examples of host adapters. So as I mentioned, we can use for data transfer objects. Also, we can use as well for dependency injection. Also, we can use as well for settings. So in this layer, in your code, it's going to be basically defining those aspects. And also we have like a few examples of adapters, host adapters that could be Fast API, Flask, Django, or if you are using message, you can as well use gRPC. Yeah, it's let's see right now a little bit about the project structure example. So I've created a simple example to try to explain how in the day by day these workflow work, these workflows it's used. So imagine that first of all we have here example of creating comments into a blog or creating comments inside invoices, for example. So the comment is something that you want to create a whole service for that. And imagine that, first of all, you need to have your adapters, right? And the adapter is going to have, like, in this case, basically two things. That, first of all, it's in-memory and MySQL, for example, that both are persistent adapters that in the end of the day, they are implementing ports that we're going to see in the next slides. That those parts are basically creating an abstraction of a comment, of something that you want to implement inside the adapter. And as well here, for example, in case you have different database connections, you can have like Mongo database folder here implementing the same things for your comment. So in the in-memory folder, it's something that people usually use in hexagonal architecture, because imagine that to test your database, you need to create integration tests. But one thing that you can do it to not actually necessarily create the integration tests that need to spin up a service that has a database test and do the whole thing around that. You can actually just create an in-memory that implements the same logic of your database adapter, and this in-memory is just going to work as said in memory, and you can basically do simple tasks inside the in-memory, and this give you a little bit of extra time to the to have a better and faster code done for your tasks. So we have here example of a domain. So we have the domain, and inside the domain we have our entities, our ports, service, and values. So it's people sometimes get usually like, hey, okay, you have ports inside your domain, and it sometimes it's weird to have ports inside the domain, but in the aspect of hexagonal architecture, since ports abstract things, and the ports is the way that we can talk directly with your domain, those ports should stay inside the domain. So for example, here we have some entities. Those entities represent the comment. So the comment has a description, or the comment has an ID, or the comment has something that like image. So this entity represents the comment by itself. And the ports here, I created an example of a repository port that's going to be basically doing the implementation of, it's doing basically the abstraction layer of your repository. Basically here we can have as well our service that you can basically create your use case of the comment. So your use case, in this case, I just put it out as name service, but you can use as well as use case. And as well, we have the values. So the values are basically really customized fields that you can have inside your entities. For example, that you need to define really specific validations. So imagine that inside the comment you have you can have attachments like image, and your image should have a name. Your image should be attached to a file, and the image actually has a date that was uploaded. So inside your values, you can create like this customized field, and this field can actually be used inside your entities to actually create a way for your validations. So talking a little bit about our hosts. Hosts, as I mentioned, are also called secondary adapters. In the host layer, you're gonna have like the whole thing about wiring up your application, about using your framework. For example, can be general, Flask, Fast API, and you can basically define those things inside the host. So here we have as well our endpoints. So the definitions of your endpoints, like get, post, put methods, delete methods, for example, you can define here. As well, you can have like the application.pipe would be something like when you start your application, you basically create like the whole wiring part of your application with the specific settings. And also your application have a container that has their own way also to wire your application. So yeah, it's pretty much around that. And here it's looking for the example complete, having our adapters, having our port domains, and our secondary adapters that are hosts. So yeah, hopefully you enjoyed this explanation. The idea is give high-level examples and explanation of base concepts of hexagonal architecture. If anyone has any question, I'm totally open. So yeah.
Yeah, thank you very much, Gabriel, for your presentation. It's been very eye-opening. It's interesting because usually when you work with web frameworks, you usually get into whatever tutorial they have on their own website, and at most they make you separate the endpoints or the controllers from the services, from the entities, all within subfolders within the, I don't know, source folder that handles everything in the framework. Whereas the hexagonal architecture is telling us to separate those concerns, separate your entities and your services from the endpoints, from the controllers, from the database migrations, and all of that architecture that comes more with the ports and rather with the adapters as well. It's rather interesting. I did see a couple of questions in the comments that could maybe go deeper into this separation. Like, for example, I see that Fausto asks, considering that the ports are defined in the core project, right, in the core folders, could you elaborate on the role of adapters in implementing those ports? What is the role of, where does one end and the other start?
Can you repeat the question, please?
Sure. So
Yeah.
just could you elaborate on the role of the adapters on implementing the ports, knowing that the ports are defined in the core project as well?
Yeah. So yeah, this is something that people get sometimes confused. But the main idea here, it's as I mentioned it, the port is the place that it's gonna actually give you the chance to talk with your domain. So imagine that external word things, for example, connecting to the database, actually doing the connection, for example, and actually doing things like that. It's something that is totally external. It's not something that represents and needs to be inside your business logic, or either is not necessarily something that you need to connect with directly your domain. So the port are basically doing, hey, I can have abstraction how you're gonna use me inside the use case, but this abstraction is gonna be implemented inside actually the adapters because they are in the external world. So why this is like built like that? So imagine that tomorrow someone asks for you, hey, we're gonna migrate our database for example, for a Mongo database. And if you need to do this migration, you actually don't need to update your repository because your repository is basically doing like the abstraction of what you want to actually do it in your adapter. So you just need to go through your adapter and say, hey, let's create an adapter that's gonna talk with our Mongo database. And this is gonna adapt and being used. Basically this is gonna like actually gonna do the whole thing around, hey, you don't need to talk directly with me because you have the port layer to help you out. So people don't need like touch, like imagine working a huge project that people need to do some sort of migration like that. People don't need to touch inside the domain. So your business logic is still like more secure in aspects of more developers touching to that. You can just create a new adapter. If something went wrong, for example, you can just revert and use the previous adapter that you had. So it's really modular, a way to see things. Also, one thing that I would like to talk, like giving a little bit of idea, for example, the host side, that is another type of adapter that's called the secondary adapter. It's also another really good idea, like another thing that we can, for example, explain. Imagine that today you need something to, imagine that today people say, hey, we actually need to build something using, for example, Django, and you created everything using Flask. So imagine this problem in aspect of your whole architecture. You're gonna need to touch in everything, but using Hexagonal, you just need to go through the hosts and just create one more new host that's going to do all the things around wiring the application, create the endpoints. Things like that get you like a faster, like get you a better way to, for example, do some sort of changes that sometimes people get really stuck because changing a framework, it's really sometimes stuck, can stuck a project. But doing by that, we know that in software development, like software engineering, things change fast. So imagine tomorrow that people created a really better host thing or a really better framework that is better than the usual, faster and things like that. You can basically like work inside this module in your hexagonal uh, repository, and then everything's gonna work out because everything is like modular and don't actually depends of your business logic. So
Uh,
yeah.
that's a rather interesting point that you bring up because it asks that you develop at least the domain part of your application, not really thinking about your framework either, right?
Yeah,
So
yeah.
you can really disconnect yourself from the framework and just use the port as the connection towards it. But that means that you have to kind of change the way that you code, because I've seen thousands of projects, and usually what you see is in the services, in the entities, all of these definitions that are very tied up to what the framework is telling you to do. So it demands that you separate those, which can maybe take a little bit longer on startup, but it can give you a lot of benefits if you need to migrate, right?
Yeah, yeah, sure. Yeah, this yeah, you're totally right. I mean, in the start point, sometimes it get really trickier to actually create your domain, which is the heart of the application because everything is self-contained inside the domain. But when you have domain done, like the other parts are basically are really like easier to make because you can basically um, change, like remove something and then add a new stuff in your adapter, and everything's going to change the in aspects of your application. So yeah.
Right. There is a new question on the chat, and it seems very interesting. It's something that I didn't think about, but given the nature of multiple adapters and ports that you're going to need in your application, does testing become more complex?
Actually, the test like depends how you like organize your tests. Imagine that, for example, you just wanted to test the layer of domain, right? Which is going to be like, for example, you don't need to test the ports because they are an abstraction layer. You just need to, for example, test like your use case. That in this case, for example, is the service, which is the actually the part of your code that is doing stuff. And also you can test as well the values that have, for example, your validations of fields. And this use like apparently people can usually see the hexagon, see that I think that the test is going to be much more complex, but I say no, the test is going to be much more easier to do because the whole part of your tests are basically testing and creating your environment test for your domain. And for example, your host layer, you can basically create a way to test, for example, that is creating the requests. You don't need to actually test doing the request because what is being used inside this is your use case. That is actually the part of the code that needs to be tested. So, for example, the host tests start to be really easier to make. Also, the layer of database, the in-memory solution that I created here is something that we usually do to not actually implement the integration test. For example, you can basically create in-memory adapter that is going to implement the same thing that your database adapter is going to do. But in the end of the day, what you need to test is going to be much more simpler because you don't need to actually create a connection with the database. and create stuff in database. Have a whole environment set up for test account, like for a testing that spin up a database and do things like that, because you can have as well inside your in-memory application. So I see that I see that I think like sometimes people get confused about the tasks under Hexagonal, but I feel much more easier to make, because the whole thing is, if you make your domain with tasks correct, like if you create like robust tasks for your domain, the other parts, it's pretty much like the host part. It's pretty much like wiring correctly your application under your framework, which don't have a lot of things to test. And the adapter side, you can have like this idea of creating in memory of your database. Sorry, in memory solution to not actually create integration tests, for example. So
All right. Yeah. I'll ask you, well, two of our questions in the chat, but just turned into one. First, could you provide any examples of real-world applications that have used the hexagonal architecture? And another one, is there a way in which we can see an example repository of the typical scaffolding that hexagonal architecture asks for?
Yeah, we have the first of all. Okay, let's answer the question about examples. So basically, we have a lot of places that people are starting to use those this architecture. I already saw in banking system. I already saw in e-commerce platforms. One like one of our clients that it's FreshBooks. It's using hexagonal architecture for some service, which give us a little bit of flexibility in our service. And also, for example, if we want to talk about another company, their assertion that they are using, it's I'm not sure if everybody know, but it's remember it's Argon company. Yeah, also it's using the hexagonal architecture. And about repositories, we have like everybody can actually go through the Google and write the name of Alster, that was the creator of the adapters import in the hexagonal. You're gonna see that Alster have his own website, that he have like a really huge documentation about explaining a few topics around the hexagonal architecture. So the best place to look for examples and for solutions and like blog and questions and comments is actually inside the Alster website, that he was the creator of the hexagonal architecture. So yeah.
Okay, that sounds very interesting. I'll have to check it out after the stream is over. That's all for the questions that we have for you. Thank you very much for the presentation and the very interesting topic that you presented, Gabriel. And thank you, everybody watching right now, for tuning in to today's episode of Lunch and Learn. If you like the topic, remember to give the video a like, subscribe, hit the bell, all that jazz, and tune in to our next episode a month from now. Until then, be you all.